Good evening, students. I'll start with the class. We will start with a new chapter. That is system of particles and rotational motion. Okay. So whenever you have any body, okay, in a random, and this body is suppose moving. So this suppose body is in motion. So we always calculate whatever is the motion and all those terms, velocity and all with respect to the particles. Okay, we randomly those particles. It is nothing but all. It's a combination of many particles together will create a body. So this is like a system of particles. So whenever we want to describe a motion, it's nothing but all the particles are in motion. Okay, whenever one second, your phone is not. Okay. So whenever I say this body is in motion, it means the system of all these particles are in motion. So we have to know what is something called as a rigid body. A rigid body is something. Suppose I take the same example. I take randomly the two particles. Suppose particle A and particle B. Okay, and this body is in motion. After certain time, it might reach here. The same one. I'm just assuming it to be the same one. Suppose if it has reached here. Okay, I will not waste time in doing that. But consider the same body. Now this is A and this is B. Now from here to here, if this is the distance, and from here to here also, if the distance has not changed, even after the movement, okay, maybe after traveling, this body has reached somewhere else also. Still, the particles distance between these two particles is the same. Means randomly I'm telling with reference to the same way. You can take any point anywhere, and that distance should not change even after the whole body has reached here. Okay, then it is called as a rigid body. As per the definition is there in the notes also. I've given your notes on this chapter. So just check. Definition is already there. Or it's there on the textbook also. If you have a normal textbook now. Rigid body, the main thing what you need to know is it has a perfectly definite shape. Now, although I have not drawn the proper shape, the shape will never change. It will remain from here to here the same. Perfectly definite shape. And the second thing, and very important, unchanging shape. The second thing, the distances between the different pairs do not change. The distance will never change. So this is the definition of a rigid body. Next we see what is a translation motion. Same thing, if there's a object which is suppose moving, there's A and there's point B. Now suppose it has gone here. Still A and B. It has reached here. Still it remains the same. So between all this will never change. So it is going in a straight line. Then it is called as a translation motion. Are you able to hear me clearly?
Yes, miss.
Okay, because I don't know, on this screen it is showing still connecting to audio. Okay, no problem. Okay, so if you see, the path is always parallel. A and B everywhere will remain the same, and it is in a straight line. This is called as a translation motion. Even on this, suppose if it is moving till here, this will come sliding down, suppose. So this is also an example of a translation motion. If you compare any two particles, they will always be parallel. Also called as a, you can say, linear translational motion. Linear means straight line. Now, why is it this? Sometimes that same object could move like this. Suppose it could come this way. Okay, imagine if this object was traveling something like this. A and B. Here also it has reached. Suppose A and B. Consider it had reached here. Then it would be A and B. No matter what, this is parallel. Okay, but what is happening? It is not a straight line. It is a translation motion only because distance between A and B is not changing. Okay, so this is a curve. Okay, curved linear, I can say, otherwise curve translation motion or curve motion. No issue because it is moving in the form of a curve. This is a proper linear motion, straight line. Okay, but what is happening? Anyways, parallel. Everywhere it is always parallel. And next what is this? A rotational motion. A rotational motion, what is the thing is? Suppose if you have any object, okay? Now suppose if this is the axis. Now what is going to happen? Rotational means it is not going to get displaced from here to here. So what you can imagine it turning around. So if this is your particle A, this is your particle B, this is your particle C. Now what is going to happen? Imagine it's turning around. So these particles will go like this. So particles are following which path? So rotational motion is in which all the internal particles follow a circular path about a, this is a fixed axis. Now if we try to join over here, suppose after some time, if this is going here, it's rotating images. After some time it must have reached on the other side. It's not spinning. I'm not saying this is spinning. Suppose if this is straight, okay, and then this whole thing is moving around like a fan, you can imagine. Best example is to take about a fan. If you consider the wings, okay, so it might, after some time it will reach somewhere else, this. So it is not going to follow parallel path. If you try to join the lines, no, see, after some time this might reach here. This wing of the fan might reach here. A, B, C. So if this is your fixed axis also you can take. So if you try to join them, this is not parallel. If A, B, C line, and if you draw A, B, C line, this and this is not parallel. After some time it might reach here, okay, around this axis. So if we join the particles, the line may not be parallel. Example, let's show you. That's a fan also, they've given one example. One is the fan, okay, and even the potter's wheel. So this is rotation about a fixed axis. The axis is at the straight line, but look at the wings, okay. Now the rod of that fan is the axis, and the wings are rotating around the rod. So that is called as a rotational motion about a fixed axis. That rod is not moving. Same way that potter's wheel, okay. So there must be something fixed below the wheel. The wheel is rotating, okay, around a fixed rod. Obviously, the wheel is not in the air. It must be fixed to something using a rod. So these are the two examples: a ceiling fan and a potter's wheel, examples of rotational motion about a fixed axis. Next is could be translational as well as, or one more example really. This was what? Rotational about fixed axis. The example is normal ceiling fan, potter's wheel. Okay, ceiling fan and a potter's wheel. This is about the fixed axis. Now the other one is rotation. I'll show you the diagram first. Now consider this situation. Now what is happening is there's spinning also and there's a rotation also. Spinning means look at the top. You can try to imagine you have twisted that top. Now this what is that top is rotating about its own axis also. That main line which is drawn with the arrow, it is rotating plus along its point. You look at that cone shape. They have drawn the circle in the path which so there are two things which are going on simultaneously. It is spinning also, okay, and rotating also. But still it is a rotational motion only. Huh? In the second case, what is happening is the table fan. Now imagine that what is that the table fan is not only in one direction. You have noticed that the that circular part can rotate in around 180 degree maybe. This side also and the other side also it is trying to oscillate. Oscillate means come back to its position from the center, go towards the left hand side and again. Now one end is fixed, the pivot. Okay, the pivot means it's a fixed position. So these are the examples of two different axes if it have. And there could be spin also, or it could oscillate also. So these are all examples of rotational motion only. That the top, so it goes within itself also. This is this also, plus it is going like this. Imagine this pen, I'm rotating among itself, plus this also. This way also it is going, plus along its own axis. It is moving, something like this. So I can give example, a spinning top, an oscillating table fan. The next step is it could be rotational and translational also. Consider this example. You keep a ball here. Obviously, the ball will not slide straight. If you keep your point A here and maybe point B here, obviously here also point A only will not come. The next moment, this point A will go up, B will come down. You know that it is rotating as well as going in a straight path. So rotational as well as translation. The ball is rotating among itself plus moving forward also. Okay, so this is an example. After some point, A might be here and B might be here. This is an example of a rotational as well as a translation motion. Circular object moving on a slope. This is not a pure translation motion. Why? You know that the lines will not be parallel. Here, what is happening? A and B is like this. Here, A and B is like this. That is not purely translational motion. Not pure. Huh? And that one, no, which I had given, that is a pure one. If it's just sliding this side, no, then this is a pure translation motion. Just write there and keep. This is a pure translation. And this is not pure. Now let's see what is the difference between a rotation and spinning. Both are examples of rotation only, but just see. This is one case. Rotation, suppose if you have, consider there's a rod. And you're keeping it fixed. One end is suppose fixed. And you apply force here. So what is going to happen? After some, obviously, this will move. Then again more force we are applying, it will move. So one side it is fixed, okay, and then it is moving. So this is one example when this is a fixed end. This is called as a pivot or pivot. Pivot means fixed end. The other type of rotation is when you have a spinning. This is not called spinning. Spinning is when you're applying force at the center, suppose something like this. Okay. Now what is going to happen? The whole this is going to spin. This suppose I'm keeping fixed, and then this is called rotation. But now from here only I'm trying to do like this from the center, then that is called spinning. Okay, this is called spinning along the center. And then suppose if I'm doing from here, this is a different way. This is using a fixed end. So this is using center of mass. Now we'll see what is that center of mass in detail. based on the center of mass. Just try to imagine you have a ball. Okay, why center of mass we take, and why is it important to study the center of mass? If you have a ball, you simply throw it up. Okay, you just go straight up, suppose, then it becomes easier. So this is a straight path. Okay, this is normal. You can always calculate very easily where is the particle. Okay, you can study particles easily. Anything you want to calculate of the velocity, everything, you can study all the particles easily. Why? Because it's going straight like this. So this is a simple motion. But now consider you are spinning the ball also. The ball is getting spin as well as you are throwing it up. So every time it is going up, so it is spinning also as well as going up. So this ball is trying to spin within itself also as well as, so it's a complex motion. Difficult to study the particles because there are so many things to be considered. At what point it is spinning also plus moving up also, it becomes too much complex. So to make this study simpler, so we consider, because there are particles everywhere, this particle might have a different velocity, this particle might have a different velocity because it is moving at means at a different speed. Okay, this is going in front, this is coming backward. It's all complicated. So we try to reduce the system to center of mass. So we ignore this spinning part, means we consider only particles at the center. So we assume, okay, we study particles only at the center. It becomes easier. So now if you are taking only the center particles, very easy to calculate, correct? This is like a particle 1, whenever it reaches here, it becomes easier to study rather than this. That is why center of mass is important. Same thing, if I throw a bottle, suppose, okay, I'll share one slide. I think it got discarded. Okay, no problem, I'll just draw and show. The image got discarded, I think. Okay, there's a, suppose I throw a bottle across this path. Suppose if it is falling, okay, it's going straight. No matter where it goes, it is always straight. This is a simple one. This is pure translation motion. Why? If you see the lines, they will always be parallel to each other. This is a pure translation motion. But now imagine this bottle is spinning also, okay, rotating also among itself and then moving. Now here what the bottle is as it is, it's going like this. This pen is going like this straight away. But imagine this like this also, the same time. So it becomes difficult. So this you have to draw. Suppose I had thrown it straight. After some time here it might bend because it is rotating also. Okay, this is rotating also among itself. So here it might reach somewhere like this. Here it might reach like this. So what is happening here? This side it is like this. Here it is somewhere like this. Here it is somewhere downwards. So these lines are not parallel to each other. So this is combination of translational as well as rotational motion. So if you actually go to see now, I want to see the path which the bottle has followed. If you actually go to see every system, this particle must have followed this. But now this particle, see from where to where it reached, it must have reached here like this. Here somewhere like this. This particle must have reached somewhere else. So it becomes very difficult to calculate every single particle here. Okay, so in general, what we consider is the center of mass, means where it is concentrated. One common point we take of the whole bottle. So center of mass, if we calculate, it follows parabolic path only we assume. Because after some time, if this bottle had reached like this, ulta, then it would be like this, something. Not necessary, no, between any two paths. It could be from here to here, then here to here, zigzag also it could. So best option is to take the center of mass. So follows parabolic path. So we generalize it instead of deciding for every single particle. So we say it is projectile motion. Projectile means whichever follows a parabolic path. Okay. So as per your understanding, what is center of mass? Center of mass is, we assume, whole at one point. Because sometimes the object at one end there will be less particles. Sometimes one side it could be heavy, that object, one end of it. But then overall in average on the heavier side, wherever there is one, wherever whole mass, like a common point we try to consider. That is like a center of mass. Why it is makes your life simpler? Consider again this example. If there is a bridge or something like that, and there is a chain which is kept. Okay, imagine there's a chain which is kept on this. This has around, I say mass is 3 kg. Calculate potential energy. A potential energy formula, is mgh. Now this is a distributed mass. What has happened is 3, only at the center it is not 3 kg, it is distributed at every single point. Now at which point to calculate? Now it's not possible, like integration you can do one part, like divide this into small parts, otherwise which height will take? Every single part of the chain will have different height, h1, h2, then what you'll have to do? Take all the pieces like this, small, 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 and then integrate everything together. That is one option, but that is like complicated option. Rather than that, if you use a center of mass, so we try to consider which is the common point, maybe somewhere here. So they calculate the height, so this distance. Okay, that there is some formula for a semicircle and all. So whatever height formula comes up, that height, common height we will use. So this is like a center of mass height. Like where is the center of mass, like common mass. So in such cases, center of mass concept helps rather than calculating every single point and then adding. So different objects have different center of mass. So just show you the slide. In general, it depends on two factors, the center of mass. One is the geometrical shape of the body and also on the distribution of the mass in the body. So whether it is a sphere or whether it is a ring or whether it is a disc, okay, anything round in shape, obviously center of mass is at the center of the circle. Even though whether it is hollow or whether it is full, center of mass will always be at the center. So rectangular will be, for the thin rod, it is at the center. For cubical, exactly shown in the figure, the points of intersection of the diagonal. So this is in general, okay. But now we'll see in detail how to calculate problems and all, how to calculate center of mass for different shapes and different particles. These are standard ones. Center of mass of a two particle system. This is important from here on, no? Because you have to calculate problems based on this. Now this is suppose in a 2-dimension, we are just checking. 2-dimension means it will be only x and y coordinate. Now consider one particle is here A, the other one is B. This one's mass is m1 and that this one's mass be m2. We always calculate with respect to the origin. So this is 0, 0. Maybe let this be r1 and this be r2. Okay. Now, whenever you have, before starting with this, I just A and B. Suppose this is also mass m and this is also mass, equal masses, they are on both the sides. And this is distance. So it is obviously understood that the center of mass will be lying exactly in the middle. If I to This will be the center of mass. Same way, suppose if you have A and B, now this is 2m, double, little heavy on this side, and this is m. You know, some way it will be more towards this side. Why? On the heavier side, it will balance. Okay, center of mass will not be exactly a center, where more heavier side. So how to calculate this over here? Now we need a formula. Okay, because it could be 3m, it could be 5m, anything. So we are trying to derive a formula. Simple formula, it is not exactly derivation. I want to find center of mass between these 2 points. So maybe it could be somewhere here, center of mass. So let that be, these are vectors, position vectors. This is r bar. So this is a common center of mass. So let that be r bar. I want to calculate position vector. Let A and B be two particles. A has mass m1, B has mass m2. No need to study the derivation. Just we are framing the formula. Only formula is important. R1, this one, position vector. This is about A. Position vector is R1 bar, and this one's position vector is R2 bar. Then center of mass position vector will be, this is the formula, m1 r1 plus m2 r2 upon m1 plus m. Okay, if you want to find the average one, position vector. If you are asked to find coordinates, coordinates means what? The points, where exactly the point is lying. So if this one has x1, y1 coordinates, x2, y2, we want to find x comma y, this point, center of mass. Okay, try to understand the difference in the problem. Sometimes they ask you for position vector. That time you have to use this letter r. Sometimes they ask you the coordinates. Coordinates means the x coordinate and the y coordinate. Suppose if I have to find x coordinate, this x, and get capital, then it is mx1 plus mx2, m1 x1, m2 x2 upon m1 plus m. Y coordinate will be m1 y1 plus m2 y2, and in 3 dimension, in 3D, if this point, they say this is in 3 dimension, then if you want to find z coordinate in 3 dimension, it would be x, y, and z axis. X and y is the same formula, only in 3D there will be extra axis, that is the z axis. So in that case it would be m2 m1 z1 plus m2 z2 upon m1 plus, is the same formula. For position vector you have to use the letter r. For x axis, x coordinate you have to use x. For y coordinate you have to use y, and in 3D z coordinate you have to use z. This is for 2 dimension. and this is for 3 times. 2D means only x and y. 3D means x, y, and z. Now, if this is along a straight line, if it's along the x-axis only. Okay, so obviously if it's along x-axis, what will be the coordinates? Maybe x1 comma 0, y-axis will be always 0. On the x-axis, the y coordinate is always 0. The x2 comma. Then the center of mass will be at x. So only x we have to find here. If the mass is along the pure x-axis, there's no point calculating y because y will be anyway 0 on the x-axis. Okay, so remember whenever this is not in a two-dimensional plane, if it's along a straight line, all both are m1 and m2, you just have to find only x. No need to find y because y will be anyway 0. Center of mass will be at this position.
Miss, this is for one dimension.
Yes, yes. So this would be one line. Now this is for two particles. Suppose if we have now center of mass of a system of particles. So whenever they give system of particles, you may have like m1, m2, m3 up till maybe mn, n number of particles. So every coordinate would be, suppose this is the distance, suppose x1 comma 0, this would be x2 comma 0, this one would be x3 comma 0. Formula is very simple, same thing. You just have to go on adding. You only two over there. Now you have to keep adding the other one. M2 x2, M3 x3, so on. Add all the masses. Based on how many particles are there, you have to keep adding. Basically mass into that distance. What is this x1? It is nothing but the distance from the origin. So this is for one dimension. So same thing if it was for two dimensions, it's understood. You have to find y, then if there were particles here in space, then y coordinate would be m1, y1, m2, y2. That no need to write. Once when you start solving the problem, you'll understand whether you have to which formula to take. We'll start solving the problems. These are simple problems actually. First one. Now we'll try to find a formula as per the formula and see. This is m and this is 2m. And suppose distance between them is given as 10. Find center of mass. whenever we are saying center of mass, we are not finding mass, we are finding the center, the position. So this always has to be taken with reference to this as 0. Okay, 1 point starting, you have to always take it as 0. So this suppose is 0 comma 0 at origin. The next will be 10 comma this coordinate. Okay, 1 you have to always assume this. So from here to here, if this is distance 10 on the x-axis, and this will be 10 comma 0 because there is no y-axis involved. So use the formula. This is x1 y1. This would be x2 y2. So m1 is m and m2 is 2m. X is what? m1 x1 m2 x2 upon m1 plus m2. Substitute m1 is m into 0. m2 is what? 2m. x2 is 10. Twenty m upon 3m. 20 by 3. Okay. So this will be 6.66. The center of mass is at 6.66 meters. If this was meters, at 6.66 meters. Maybe here. X is nothing but the distance from the origin. Now there are some problems which are there on your notes. Those questions I'm not going to write. You can refer. I just share the slide. We'll solve this problem. In HCl molecules, the separation between nuclei of two atoms is about 1.27 A naught. Okay, that I'll tell what is A naught. Or find the approximate location of the center of the molecule given that the chlorine atom is about 35.5 times as massive as hydrogen atom, and nearly all the mass is concentrated in its nucleus. It's at the center of the nucleus. What they're trying to say is that there are two molecules or two atoms. One is hydrogen, the other one is chlorine. The separation of the two is about 1.27 A naught. Does anyone know what is that A naught? I have heard about it. I think in chemistry I must have done that. Something called as Angstrom's number. Okay, Angstrom's. So remember, in case you don't know, it is 10 raised to minus 10. 10 raised to minus 10 meters. Not needed also actually. Okay, you can just avoid that if in case you don't know, suppose. No need to calculate because final answer can write it as a naught only. You just avoid. Okay. So now distance is just assume it to be 1.27. Forget about the unit. Now this we have to always take 0, 0. So this how much it will be? 1.27, 0. Because x2 is how much? 1.27. x1 is anyway 0 starting point. Mass how much is given? m1 is as huge, as massive means how much is the mass of it? So 35 point. Okay, m1 is of what? Okay, mass of hydrogen or mass of chlorine is 35 times hydrogen. So this is m1, this is m2. m2 is 35.5 times hydrogen. Okay, now use the formula. m1 is, keep it as m1 only. Okay, keep hydrogen mass as m1 only. x1 is 0. Now m2, instead of m2 I'll use this 35.5 times, what is that? m1 into x2 1.27 upon m1 plus 35.5 times m1. Both are m1, no? So instead of m2 I'm using this. Now calculate. This is anyway 0. Now multiply 35.5 into 1.27 times m1. Take m1 common. 1 plus 35.5 times m1. m1 will cancel. From here, both the terms I took m1 common. Answer will be this, you multiply upon 36.5. Then you calculate. So whatever answer you get now will be that much A naught. Write the units in terms of A naught now because that is not meters. So it will be 1.235. Next problem. Second question says the position vectors of the center of mass of three uniform spheres of masses 1, 2 and 3 kgs are, there are some position vectors given. Okay, so R1 is given, R2 is given, R3 is given. So I also is there, J also is there, K is also there. It's a three-dimensional one. But coordinates are not asked to find out. X, Y, Z you don't have to find. You just have to find position vector. So find a position vector of the center of mass. So basically R you have to calculate. So assuming now there are three mass. So maybe this is the origin with respect to that. There are three masses. We don't know where exactly. So randomly This is one sphere, this is another, this is another. M1 is of 1 kg, M2 is 2 kg, and M3 is 3 kg. R1 bar is given, R2 bar is also given, R3 bar is also given. Maybe somewhere between them, somewhere center of mass is there. We don't know where exactly. So I'm not drawing that center of mass. It may look confusing. We don't know where exactly. Somewhere in between these three will be lying the center of mass. The center of mass is R bar. We have to calculate. So what is R1 given? I cap minus J cap. R2 bar is given as 3 I cap. And R3 bar is given as, it will all be given in terms of vector form. This is a vector form. Now already I've given you the formula in terms of position vectors. Obviously there are 3 particles, means you have to apply for 3 things. M1 R1, M2 R2, M3 R3. I had given up till 2. Now if there are 3 mass, you'll have to extend the form. These are vectors. Upon so just substitute the values. M1 is 1 kg, R1 is this, M2 is 2 kg, M3 is 3 kg, this will be 2 plus 3 kg. Now open up the bracket, bring all I terms together, J terms together, K term, and write final answer. Open up the bracket and then simplify. 7 minus 3. See, I'm calculating directly. 1 plus 6 is 7. 6 minus 3. All the i's I've calculated. 1 plus 6, that will be 4i. J is here. So minus 3 plus 2 is 5. 5 minus 1 is 4 J cap. And then K cap is plus 2 K cap minus 2 K cap will cancel. Upon 6. You can either leave your answer like this only, or you can simplify. You can distribute this. Two by 3 I cap after cancelling. 2 by 3 J cap minus 1 by 2 K. This is the R bar. This is the position vector of the center of mass. So center of mass lies at this position. Next question. Before solving next one, the square one. So in general, I'll tell you what happens in a square. Now there are values given. Suppose if there were no values given, how to find center of mass of any given square? There are 4 points in a square form. This will be anyways M1, M2, M3, M4. You know, for sides, all the sides of a square will be equal. Consider square of side A. This is not, in the next question is not actually square, but I solve the 7th one first. Okay, question number 7. Now, for this point, normally we take as origin. One point always you have to take as a reference at the starting point. So this is 0, 0. Now this is what your x1, y. Same we have to find what is x2, y2, x3, y3. Coordinates I have to find now. Because without that we cannot solve the problem. Because formula will be straight away we have to find x and y now. Because it is 2-dimension now, not on a straight line. It's not only on the x-axis, it's going on the y-axis side also. So as per that, suppose this is on the x-axis. From here to here, how much distance has it traveled? 0 to a. So this will be a comma 0. From here to here is a comma 0. From here to here, it's on the y-axis. So y-axis point will always be 0 comma a. Because y is 0 comma a, y-axis. And this is on the x-axis. Now this, from here to here, how much is this distance? X distance is how much of this point? A. Y distance with respect to origin. Just draw this in the graph form and see. From origin, okay, this distance, X distance is A, Y distance is A. So this points will be A comma I. So question number 7 says there are 4 particles, okay, of mass m, 2m and 2m, which are placed at the 4 corners of a side of a square. So m1 is given as m, m3 is 2m, m4 is given as 2m. M, 2m, 2m. Now square of side A has been given. Calculate the center of mass. So center of mass means we have to calculate x-axis as well as y-axis. So for x part, m1, x1. So this is x2, y2, x3, y3. Now substitute m into 0, m into a, 2m, m3 is 2m, into a, 2m into 0, upon m plus 2m plus 2m. So 1 ma, 2 ma, so total, and this also will be 0, no? Two, 6, 5m upon 6m. M and m will cancel. 5 upon 6 times a is the x coordinate. sorry 3, no, sorry, this is 3. 1 plus 2 is 3, so this will be 3. So 1 by 3. Okay, 1 ma is nothing is there means coefficient is 1. 1 plus 2 is 3. 3 ma. So that's the x coordinate. Same way we have to calculate y coordinate now. So write a formula in terms of y. So this whole thing will change as y. And this is fine. M1, this is same. Now substitute your y coordinates. M1 means m into 0, y coordinate. M2 into again 0. M3 means 2m into a, 2m into this anyways is 0. 2 plus 2 will give me 4 ma. 2 upon 3a. So we got x coordinate and y coordinate. So I have to write it as a point now. Center of mass may be somewhere. So center of mass is always x comma y. So what was the x value? 1 by 3a. That will be 2 by 3.
Excuse me, Miss.
Yes.
Miss, how did you get the values of M1, M2?
Given in the question. 4 particles. Yeah. I'll just, notes are not there with you all. Okay, wait. I'll just share the question. Yeah. Question number 7. 4 particles, masses of m, 2m, and 2m are told. Before question number 7.
Okay, Miss.
So same way now we'll solve question number 3. It's not a square, but now they have given the distance. So I'm solving question number 3. I'll just draw the diagram. M1 is 1 kg. I'm just writing as 1. M2 is given as 3 kg. M3 is given as 2. Okay. Kg if you want to write. No issue. And this distance is given as 3 meters. And this is given as 5 meters. You have to find center of mass of this diagram. Now this obviously I'll take it as 0, 0. So this will be what? From here to here will be 3, 0. Because from here to here distance is 3. Now here to here it is 5. But we are on the y-axis. Okay, now before that, this is in the middle. This is not even on the x-axis as well as y-axis. This is middle of x as well as y. Now what? How much is this distance? Same as this, because the rectangle. Obviously, if this is 5 means this will be also be 5. Parallel line. So 5 means this will be 5, 0. Sorry, 0, 5. On the y-axis, x part will always be 0. This distance, x is 3 and y is 5. This will be 3, 5. X distance is 3 of this point from the origin. and y distance is 5. Now you apply the formula. This is x1, y1. X will be x1, y1, x2, y2. Sorry, m1, x1, m2, x2. m1 plus m2 plus m3. 1 kg into 0, 3 kg into 3, 5 kg into 3, sorry, 2 kg, and 4 kg into 0. 1 kg, 3 kg, 2 kg, 4 kg. Then calculate. Same way y also. m1, y1. Apply the formula. This will be 1 into 0, 3 into 0, 2 into 5, and then 4 kg into 5. So understand what is m1, x1, only diagram, and then it's just pure substitution. Anyone having doubt, you can ask. I think this should turn out to be 9 plus then 5. Just confirm your answer. Then okay, this should be 1.5 and this should be 3. So center of mass will be 1.5 comma 3.
Miss, the unit will be meters, right?
Yeah. Next question about the equilateral triangle. So in general, I'll tell you when any value is given, you can formulate. Suppose if it's an equilateral triangle, how to find center of mass. Equilateral triangle means you know all the sides are equal. This you will take reference as suppose 0 comma 0. Imagine this is on the x and the y axis. Now from here to here you have traveled distance a. This point will be a comma 0 on the x axis. And now this we have to find. How to find is, there's one option. You know that this is 60 degree. Equilateral triangles means all are 60 degrees. So just make this perpendicular, draw perpendicular. If this full distance is a, then obviously this will always cut into two equal halves the perpendicular line. This is a by 2, this side. This side is a. I want to find which is this side. Okay. So any angle you use, the cos 60 or cos this year I'm taking as cos theta. Cos theta is okay adjacent upon. Okay, I want to find this side now. I use sin theta, opposite I want. So sin theta is opposite upon hypotenuse. Otherwise, you can use this Pythagoras theorem formula. What is this side? Hypotenuse square minus side square. That way also you can do. Using Pythagoras theorem, you can find this third side. Because finally, I want distance from here to here. To find coordinate of this. X coordinate is anyways a by 2. Because this distance, x distance is a by 2. I want to know what is the y distance. So I'm using sin theta formula. Sorry, sin theta formula. So this is sin 60. So opposite will be, we have to find which is this opposite side. So I'm considering this opposite side. So hypotenuse is how much? A. So sin 60 is root 3 by 2. And A will go here. So remember, opposite side, if you want to by heart and keep, you can by heart. This for an equilateral triangle, no? This one, this length will always be root 3 upon 2 times A. This is fixed. This side. So what will be the y distance? The y coordinate. Okay. So now we'll solve. I'll just frame the question and give you. Then it's simple to solve. So question number 4. Question number, directly I'll draw the diagram. There's an equilateral triangle. All the sides. This is M1 is 3 kg, M2 is 4 kg, and M3 is 5 kg. Everything is 1 meter. So A is 1 now. So this will be 0, 0. This will be 1, 0. Just put substitute. And this will be A by 2 because this distance will be half from here to here. So X distance of this point is half. And Y distance I told you is always root 3 by 2 into A. So straight away it will be root 3 by 2. So this is x1, y1, x2, y2, x3, y. Now you know how to solve. The formula will be only of 3 particles now. X will be m1, x1, m2, x2. Same way y also, m2, y, m1, y1. So this is what? 3 into 0, 4 into 1, 5 into half. And this will be 3 into 0, 4 into again 0, 5 into 3 root 3 by 2. The answers are there given on the notes. You can just then calculate and confirm. Same way you can calculate, solve the other problems also. The last eighth one. Eighth one is very simple. You don't even have to find the coordinates. Eighth one straight away. Distance is given 0.5 m1. M2 is, this is eighth one. M2 is 1.0 kg. This is 1 point. So coordinates, this is 0, 0. This distance is given 4 centimeter. This is given 3 centimeter. So this is 4, 0. This will be 0, 3. That's it. Straight away right angle triangle. So x1, y1, x2, y2, x3, y3. Because y distance is 0, 3. Sixth one also is same equilateral triangle. Only this, what is the mass is different. I'll stop here. Okay, those are finished. Can